Chapter 5, Section 5 is about direct variation. So by the end of this lesson, you should be able to write an equation of direct variation, and you should be able to use ratios and proportions with direct variation. So what exactly is direct variation? So as you watch a movie, 24 individual pictures or frames flash on the screen each second. Here are 3 ways that you can model the relationship between the number of frames and the number of seconds. So first we showed it in a table. Next, we showed it in a nice little graph, and then lastly as a function rule or as an equation. So using the table, graph, and function rule, I want you guys to pause the video and answer these 5 questions. Alright, hopefully your answers match mine. As the number of seconds doubles, what happens to the number of frames? It also doubles. We can go back and take a look here. If I go from 1 to 2, 24 to 48 is doubling. And if I double 2, I'd have to jump to 4, and 48 times 2 is 96. Find the ratio of the number of frames per second for each pair of data. So the first one's easy, it's just 24 over 1. But then this next one's 48 over 2. But if you simplify it, you still get 24 over 1. Same thing with 72 over 3. For every increase of 1 second on the horizontal axis, the increase on the vertical axis is 24. So if I go over 1, this is up 24. Over 2, it's up 48, on and on. So then what do you notice about your answers to question 2 and 3 and the coefficient of s in the function rule? So this is 24 right here. Well, hopefully you notice they're all 24. And then what number of frames corresponds when time equals 0, or the number of seconds is 0? And if you go back right here, we can see the number of frames would also have to be 0. So then your ordered pair is 0, 0. So the reason we did that is to help better understand what direct variation is. That table in the activity shows the number of frames in a movie that are projected over various lengths of time. The ratio always stays the same. It says that it's constant. The number of frames is proportional to the time, and 24 is the constant of variation. So a function in the form of y equals kx, k can't be 0, is a direct variation. The constant of variation is k. The variables x and y are said to vary directly with each other. So this looks very similar to y equals mx plus b, except 2 important differences. First of all, we use k instead of m, but they kind of mean the same thing. Here we call it the constant of variation, and here we call it the rate of change. But either way, it's what it's changing by. It's this ratio of change, and in the last problem it was 24. The other huge difference here is there's no b. Your b is always 0 for direct variation. So that means because it's always 0, it has to pass through the point 0, 0. If it does not, if it has a y-intercept, then it is not direct variation. So is each equation direct variation? If it is, find the constant of variation. So we need to put these in kind of y equals mx plus b order, but in y equals kx. We're looking for 2 things. We want the constant of variation if we don't have a y-intercept. So the first one, let's get y by itself. I'm going to have to divide by 7. So I get y equals 2/7 x. This is direct variation because there's no y-intercept here. And my constant of variation is whatever your slope is, whatever it's changing by. And it's changing by 2/7 every time. Now the next one's a little harder. We got to get y by itself, so I'm going to subtract 4x from both sides. I get 3y equals negative 4x plus 8. Divide by 3. So I get y equals negative 4/3 x plus 8/3. This is not direct variation. And the reason is we have a y-intercept. That can't happen. Let's try one more. Get y by itself, so this time I'm going to have to add 7.5 to both sides. So I get y equals 7.5x. Now again, this is constant variation because there's no y-intercept there. or direct variation. My constant of variation is that 7.5. That's what it's changing by each time. Another type of problem you're going to see is it's going to tell you to write an equation of direct variation that includes the point, whatever. In this case, it's -3, -6. So what we're going to do is remember direct variation equation looks like y equals kx. Now we don't have the k, but we can find it. Remember, a point is x comma y. So we can plug that in and figure out what k would have to be in order to make this point true. So for y, I'm going to plug in -6. Still have k, and for x, I'm going to plug in -3. And then we can solve for k. So I'm going to divide both sides by -3. So I get 2 has to be the value of k. That is my constant of variation. So my equation is going to look like y equals 2x. And now this point is on that line, and millions of other points are whenever I plug something in for x. So we can rewrite a direct variation equation like this. This is basically what we just did. We solved for k. We took what my y equaled, which was -6, and divided by x, and that gave us k. So when two sets of data vary directly, this ratio is a constant of variation, and it should be the same for each data pair. So for the data in each table, tell whether y varies directly with x, and if it does, write an equation. So what we want to check is if we do y divided by x for all of these, do we get the same number out? So 3.2 divided by -2 gives us -1.6. 2.4 divided by 1 gives us 2.4. This next one, 1.6 divided by 4, gives us 0.4. These are not the same. So that means that even though there might be a relationship there, they do not vary directly, so we can't come up with an equation that looks like y equals kx. So y does not vary directly with x. So let's try the next one. Remember, we want the ratio of y divided by x to be the same. So 6 divided by 4, that gives me 1.5. 12 divided by 8, that also gives me 1.5. 15 divided by 10, guess what? 1.5. So because those things are the same, we know that this varies directly. We can come up with an equation that looks like this, and what we just found right here, that ratio, is our k. So our equation is y equals 1.5x. And that's it. So, can you write an equation of direct variation that includes this point here? And then use your ratios to solve this physics problem. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.